In our lesson today, we're going to be looking at algebra word problems. Okay, and so there's lots of different words that we're going to have to be aware of. One of the big things you're going to have to be able to do today is determine if the question is representing an equation or if the question is representing an inequality. Okay, and back when we talked about expressions, when we translated verbal expressions into algebra, we had a very big list of words that we needed to know that represented specific operations. Okay, so we can see this list in front of us here. All right, so sum would be an addition. Okay, difference means to subtract. Product means to multiply. Quotient means to divide. Those are the big four: sum, difference, product, and quotient. But we have other ones as well. Increased by is an addition word. Divided by is pretty obvious there. It's division. Twice means to multiply by 2. Times is multiplication. And triple means to multiply by 3. Okay, in the next column, if we have more than, that represents addition. Decreased by is subtraction. Less is also subtraction. The word of, when it's with a fraction, like a half of something or a third of something, this is going to be multiplication. You multiply the fraction by the value that they're talking about. Fewer means to subtract. Minus you knew is subtraction. Multiplied by is multiplication. Diminished by is subtraction as well. And if they want the total of two things, we need to add them together. Now, we have 3 switch words here: less than, take from, subtract from. They all represent subtraction, but when we are less than a number, or if we're taking something from a number, or if we're subtracting from a number, you need to switch the order from the words to the algebra so that you set up the problem correctly. Okay, looking at a couple of more things here. When they say a number, they're not being specific in telling us exactly which number it is they want us to use. So when they say a number, we're going to be using a variable to represent that unknown number. And then finally, the word is. Is the result, is the same as, is means equal. Okay, is means equal. So you're going to be using your equal sign when you see that. Okay, when we're looking at word problems here, there's a series of steps that we're going to follow. We're going to define our variable by writing something called a let statement. And then we're going to write our equation or inequality, because in some cases we might be working with an inequality. We'll solve our equation or inequality, we'll perform some sort of a check, and then we'll make sure that we write a final statement that answers our question. So looking at example number 1, it says 4 times a number increased by 7 is the same as 63. Find the number. Well, what are we looking for? We're looking for that unknown value, all right? The value of the number. We don't know what number it is that they're talking about. That's what we are looking for. Okay, so the first thing we're going to do is define our variable, and we're going to say let n, I'm going to use the variable n, equal the number. Okay, so the variable n is going to represent the number that we are looking for in this problem. Okay, in step 2, I'm going to set up my equation or my inequality. Okay, and if I read through the words very carefully here, all right, when I say 4 times the number increased by 7 is the same as 63, well, I know that that's going to be an equation because it's setting it equal to some specific value. So at the end, I'm going to have something that equals 63. Now I need the rest of the equation. It says 4 times a number, so I'm going to do 4 times some number, which I've just called n, so 4n, and then increased by 7. Increased means to add, so I'm going to have 4n plus 7 equals 63, is the same as 63. Now I need to go through all of my algebra and figure out what the value of n is. This is a 2-step equation. The variable is on the left-hand side of the equal sign, but it's not alone. It's got that constant 7 with it. So in order to get the variable term alone, I'm going to subtract 7 on both sides. When I do that, on the left, 7 minus 7 is 0, leaving us with 4n. And on the right, 63 minus 7 is 56. So 4n equals 56. But we want the value of just one n. Right now, n is being multiplied by 4, so we're going to go ahead and divide by 4 on both sides. Okay, when we go ahead and do this division, 4n divided by 4 is the one n that we want. And it's going to be equal to 56 divided by 4, which is 14. So there's our third step. We just solved for the value of n. Now looking at my 5 steps, the next thing I'm going to do is the check. So step number 4, I'm going to do a check. And the original equation was 4n plus 7 equals 63. I'm going to replace n with my answer, which I think is 14. So 4 times 14 plus 7 equals 63. And now if I follow order of operations, 4 times 14 is 56. And finally, if I do 56 plus 7, I do get 63. So 63 equals 63, and it checks. And now the last thing I need to do is write a final statement. Okay, I was looking for the value of the number. So I'm going to say the value of the number is, and then I'm going to use my answer, 14. The value of the number is 14. So those are the 5 steps that we're going to set up in our word problems. Make sure you've got the 5 steps numbered just the way that I've got them numbered right now. In example 3, it says, as a salesperson, you paid $50 per week plus $3 per sale. This week, you want your pay to be $155. Find the number of sales you need to make in order to earn $155. So again, what are we looking for? Well, it says find the number of sales. So we are looking for the number of sales that we need to make. Okay, so in step number 1, I'm going to say this time let n, my variable, equal the number of sales that I need to make. And I'm going to use that variable now in either an equation or an inequality. Well, it says right here that you want your pay to be $155. You want it to be exactly $155. So this also is going to be an equation. So I'm going to have something, and at the end it equals 155. Okay, so now I need the rest of my equation. It says, as a salesperson, you get $50 per week plus $3 per sale. All right, so we're going to get that $50 this week, no matter how many sales we make, but we're going to add on $3 for every sale. So $3 times n, which again was our number of sales. And so this is the equation that we're going to use. So let's go ahead and do the algebra now. The variable term's on the left. It's got the constant 50 on the same side. So we're going to start by subtracting 50 on each side. On the left, 50 minus 50 is 0, leaving us with 3n. And on the right, 155 minus 50 is 105. Now we need to get the value of n. N right now is being multiplied by 3, so we're going to go ahead and divide by 3 on each side. When we do that on the left, 3n divided by 3 is our 1n. 105 divided by 3, n equals 35. And so there's step number 3. We just solved the equation. Let's go ahead and check just to make sure that we did it correctly. Step 4 is the check. Our equation said 50 plus 3n equals 155. And we think that n is 35. So let's go ahead and replace n with 35 in our equation. And now use your order of operations. I'm going to multiply before I add. 3 times 35, well, that's 105. So we have 50 plus 105 equals 155. And then if we actually go ahead and do the addition, 50 plus 105 is 155. So 155 equals 155, and it checks. And now I need to write a final statement. Okay, so again, what were we looking for? We were looking for the number of sales. And so we just found out that we need to make 35 sales. So we're going to write, you need to make 35 sales to earn $155. In our next example, we're told that Claire's mom found a very good price on a large computer monitor. She paid $325 for the monitor. This price was $65 more than half of the original price. So what was the original price of the computer monitor? Okay, that's the question that we're trying to figure out. What was the original price? So when I define my variable this time, I'm going to say let n equal the original price. N equals the original price. Okay, so now we've got to put all of this together. All right, Claire's mom paid $325. She paid exactly $325 for it. So this again is also going to be an equation. So at the end, I'm going to have something that equals $325. Okay, and it says that the price that she paid was $65 more than half of the original price. Okay, so she's going to pay $65 more than half the original price. So I'm going to take the original price, which was n, and to find half of that price, I'm going to multiply it by a half. So 1/2 times n. And then I need $65 more than that, which means I'm going to add 65. Okay, so the price $325 is equal to 1/2 n plus 65. This equation is going to allow us to figure out what the original price of the computer, the computer monitor was. So let's go ahead and solve this two-step equation. The first thing that we're going to have to do is isolate the variable term on the left by subtracting 65 from each side. Okay, so if we go ahead and we do this, 65 minus 65 is going to be 0, meaning that we only have 1/2 n on the left. And if you do 325 minus 65 on the right, that gives you 260. So 1/2 n equals 260. Now we need to get the value of n, all right? N is being multiplied by the fraction 1/2 right now. Instead of dividing by the fraction 1/2, we can multiply both sides by 1/2's reciprocal, which is 2/1. All right, so I'm going to multiply by 2/1, which is the same as 2. So I'm going to multiply by 2 on the right-hand side. And let's figure out what happens here. On the left-hand side, 2/1 times 1/2, the 2's can simplify down to 1's. So we have 1/1 times 1/1 n, which is just n. And on the right, 260 times 2 is going to be 520. So there's step 3, n equals 520. Let's make sure that we've done this correctly. Number 4, the check. Okay, the original equation said 1/2 n plus 65 is equal to 325. And we think n is 520. So I'm going to do 1/2 times 520, and I'll put it over 1, plus 65 equals 325. We're going to go ahead and multiply the two fractions first. 1/2 times 520. The 2 and the 520 can simplify. 2 goes into 2 once. 2 goes into 520 260 times. So 1/1 times 260/1 is 260. Bring down plus 65 equals 325. And now if you add 260 with 65, you do get 325. 325 equals 325, which checks. And so the last thing we're going to do is write a final statement. Now, again, we were looking for the original price of the monitor. So we can say the original price was $520, which we just found here in step number 3. In the next section, we're going to look at inequality word problems, okay? And there are some key words that give away if you're working with an inequality versus an equation. One of those key words that we're going to see here are the words at least. If I see the words at least, I know I'm going to be working with inequality. But the question is, which inequality are we going to be using? So in question 1, if I said I wanted to make at least $10, what does that mean? What are some possible dollar amounts that I would be happy making? Well, if I wanted at least $10, that means that if I made $10, that would be good. But I'd also be happy with making $11 or $12 or $13, etc. So notice it's $10 or more. Example 2, if you wanted at least 8 people at the party, what does that mean? Okay, at least 8 people. Well, you'd be happy if 8 people showed up, but you'd also be happy with 9 people, 10 people, 11 people, 12 people, etc. All right, so 8 people or more. If you wanted at least an 85% on your vocab quiz, what does that mean? What are some scores that you would be happy with? Well, if you wanted at least an 85, well, you'd be happy by getting an 85. And you'd be happy by getting an 86, an 87, an 88, all the way up to a 100 you would be happy with. So 85 or more. Okay, so for the symbol that we're going to use for at least, notice we can be equal to the amount that we're looking for, but we also want to be greater than that. So the symbol for at least is greater than or equal to. Okay, another set of words that represent an inequality is at most. If you wanted to spend at most $40 on a game, what does that mean? Well, you would pay $40 and be okay with that, but you'd also be happy just spending $39, $38, $37, all the way down to, if you could get the game for free, that would be nice, okay, $40 or less. If you wanted to have at most 4 people over for dinner, what does this mean? Well, at most 4 people, if 4 people showed up, that's good. But I'd also be happy with 3 people, or 2 people, or 1 person, and I can even put 0 on there, even though it wouldn't be much of a dinner. 4, 3, 2, 1, 0. 4 people or less. So if we have the words at most, notice again, we can be equal to the number that we're looking for, but we can also be less than that. So for at most, we're going to use the symbol less than or equal to. Okay? Similarly, the words maximum and minimum represent inequalities as well. Maximum. The maximum score that you can get on a test is a 100, so you can get a 100 or less. All right, so for maximum, we're also going to use the symbol less than or equal to. Minimum. The minimum score that you need to pass a test is 65. So in order to pass the test, you would need a 65 or higher. So we're going to use greater than or equal to when we see the words minimum. In example 3, it says Matt works as a carpenter. He was paid $65 today for supplies, and he's also paid $25 per hour. Matt would like to earn at least $225 today. How many hours will he need to work? Okay, so that's what we're trying to answer. How many hours will he need to work? So when I do my let statement, let n equal the number of hours worked. That's what we're trying to determine. How many full hours do we need to work? And now in step 2, I'm going to set up my problem. Now, notice right here, it says at least $225. Well, that means that Matt would like to earn $225 or more today. So for our problem, it's not an equation, it's an inequality. And since it's $225 or more, we're going to have greater than or equal to 225. Okay, at the end, greater than or equal to 225. Now we need to set up the rest of the problem. It says he gets paid $65 for supplies and $25 per hour. So we're going to get paid for the $65 for the supplies, and then we're going to get paid $25 per hour, which was my n, the number of hours, and I would have to add these two together to get my total pay. So this is the inequality that we're going to solve. 65 plus 25n is greater than or equal to 225. Let's go ahead and isolate the variable term on the left by subtracting 65 from each side. That'll get our variable term alone. 65 minus 65 is 0, so on the right, we're only left, on the left, we're only left with 25n. On the right, 225 minus 65 is going to be 160. And subtracting will preserve the symbol, so 25n is greater than or equal to 160. Now we need to get the value of n. N is being multiplied by 25 right now, so we're going to go ahead and divide by 25 on each side. And when we do this, 25n divided by 25 is our n. 160 divided by 25, if we punch that into our calculator, we get 6 4/10. And since we divided by a positive number, we're going to preserve the symbol again. So n is greater than or equal to 6 4/10. And so there's our third step. We just solved the inequality. Now we're going to pick a value to check. So for the check, again, we're going to rewrite the original inequality, which was 65 plus 25n is greater than or equal to 225. Now, looking at our answer from question number 3 right here, all right, we can't work the partial hours, okay? I can't work 6 4/10 hours, okay? So I'm going to have to pick a value, a full number of hours that's bigger than 6 4/10. Well, that would have to mean I'm going to use 7 hours as my value when I do my check, okay? Again, I can't work 6 4/10 hours, and I need to be greater than or equal to 6 4/10. So I'm going to use 7. 65 plus 25 times 7, is that greater than or equal to 225? Hopefully it is. Well, if we multiply 25 by 7, okay, that's going to give us 175. So 65 plus 175 is greater than or equal to 225. And now when I go ahead and do my addition, 65 plus 175, that gives me 240. Is 240 greater than or equal to 225? Well, yes, it is. 240 is greater than 225, so that equation, that inequality will check. And now I'm going to go ahead and write my final statement. Okay, so again, Matt can't work 6 4/10 hours, so in order to make at least $225, we're going to say Matt needs to work at least 7 hours. In our next example, we're told that at an amusement park, they charge $6 for admission plus 76 cents for each ride. If you have $20, what is the maximum number of rides that you can go on? Right there's the question that we need to figure out. What's the maximum number of rides that you can go on? So step 1, let's define n. Let n equal the number of rides that we can go on. N equals the number of rides. Step 2, let's set up the problem now. They want to know the maximum number of rides, okay? We have $20 to spend. We can't spend any more than that, so we can spend $20 or less. So at the end of our inequality, we're going to have less than or equal to $20, okay? The amount that we spend has to be less than or equal to $20. Well, at the amusement park, we have to pay the $6 admission, and you only enter in once, so $6. And then it's 76 cents for each ride. We're going to go on n rides. So we're going to do 76 cents times n, the number of rides. And I'm going to have to add the admission to that in order to figure out the total amount that I have spent. So 6 plus 76 hundredths n is less than or equal to 20 is the inequality that we need to solve. Okay, the variable term is on the left. It's got the constant positive 6 with it. So we'll start by subtracting 6 on each side. On the left, 6 minus 6 is 0, leaving us with 76 hundredths n. 20 minus 6 is 14, and subtracting will preserve the symbols. So 76 hundredths n is less than or equal to 14. Now let's get the value of n. Okay, n is being multiplied by 76 hundredths, so we'll go ahead and divide each side by 76 hundredths. And so looking at this on the left, 76 hundredths n divided by 76 hundredths, well, that's just going to be the one n that we're looking for. And now if you punch into your calculator 14 divided by 76 hundredths, all right, you're going to get a really nasty decimal, okay? So we're going to write out all of those decimals, all right? So we're going to have n, we're going to have 18 and 4, 2, 1, 0, 5, 2, 6, 3. That's what you get on your calculator. when you do the division. And since we divided by a positive number, we're preserving the symbol. N is less than or equal to that decimal right there. So there's step number 3. Now we're going to pick a value for our check. Step 4 is the check. And the original inequality said 6 plus 76/100 n had to be less than or equal to 20. Now again, look at your answer here in step number 3. You can't go on 18.4210 blah, blah, blah number of rides, okay? You have to go on a full number of rides that's less than or equal to that long decimal. And so what we're gonna do then is use the number 18. 18 is less than or equal to that decimal. So I'm gonna substitute 18 in for n, and now I'm gonna go ahead, I'm gonna follow the order of operations. I'm gonna multiply first. 76 cents times 18, if you punch that into your calculator, all right, you're gonna get 13 68/100. So 6 plus 13 68/100 needs to be less than or equal to 20. And now if you go ahead and add 6 with 13 68/100, you would get 19 68/100, or $19.68. Is that less than or equal to $20? Well, it sure is. All right, so that inequality checks. And this means now in step 5, remember, we were looking for the maximum number of rides that you can go on. So we're going to say the maximum number of rides you can go on is 18 rides.